Hey everyone, today I'm gonna do a full walkthrough of the LLM plus automation framework studio template which I built for you to easily incorporate large language models into your automation. At the back end, this is using Langchain framework, Python API, um, and that can be used along with the custom activities. But before I go into the different components, let me show you the different challenges that it's trying to solve. Of course, as you know by now, large language models are very powerful, and how we can leverage or optimize its power is by being able to provide our own data or context so that it won't hallucinate based on the what it has initially been trained with, right? So it would require proper integrations, frameworks, and guardrails. So that's why I built this LLM framework, which basically also resembles RA framework, but with additional sets of activities, custom activities included in the workflow, strategically placed in different modular components, which I will cover in a bit. So what this brings is it makes sure that you can conserve token, not only making your large language model calls context aware, right? But it also conserves the token by being able to fetch the most relevant chunks from the data sources that you provided, because LLMs can only fit so much words in a single call, and you don't want to fit a 100-page document into a large language model. So what this activities provide is a way for you to ingest sources and be able to use those sources in your automation or conversation with the large language models, right? So that's why it has this LLM powered custom activities using Langchain framework. I will provide the usage link on how to use this activity in the description below, so be sure to look at that guide. And for this particular session, we'll focus on the studio framework, studio template that is used to orchestrate these activities in order for you to tackle either conversational or transactional use cases, where conversational use cases are chat based, being able to interact in a context aware, memory backed, large language model, not just calling a model, not just calling a generative AI, but being able to incorporate your own data sources and chat with memory, basically. While the transactional is a typical transaction-based framework using queue and being able to use interact with large language model, incorporate that into your automation. I will provide use cases as we go along this tutorial. So this is how the LLM Framework Studio template looks like, which has the different state machines depicting the different steps that can cater both transactional and conversational use cases, which are fully documented, by the way, comprehensive documentation, annotations for and how they're how to use for transactional and for conversational use cases, including the global variables that are defined and sample implementation that I will cover in a bit, like right here. And this has full documentation in the marketplace link that this framework is published. So let's see first the building blocks. When I say building blocks, the main custom activities that this framework is using, which also has, as mentioned earlier, is published separately in the marketplace. So it has full usage guide in that particular link, which I will provide in the description, which these are those activities. So basically you use these activities in the framework. These activities are being used all over the framework, where you ingest knowledge source and converse with context, and you provide a source, whether the source can be CSV, PDF, or currently supported sources, a YouTube link, a Word document. So those are the 4 currently supported sources as of this time, and you use those sources as a reference or context when interacting with the LLM, where you can choose the currently supported LLM providers, Anthropic Claude or OpenAI GPT. If you choose OpenAI GPT, it uses GPT-4 June 2013 as an LLM model, and you can, if you don't provide the LLM model name, and you can see other LLM model for OpenAI in this link. In this link with limits. So these are the available LLM models. Or if you select OpenAI, if you select Anthropic Claude, and the default will be Claude 2, and you can also use Claude Instant if you want to use Claude Instant model for Anthropic Claude. So, and of course, you have to provide the corresponding LLM API key depending on which LLM provider that you choose. Again, the full setup and usage for these activities can be found on the corresponding marketplace link for the LLM Framework custom activities. So once that's the activities that are being used within this framework. Now let me show you a sample basic usage of these activities. So this is ingesting the sources from this sample CSV file, and by sources I mean different document with different document types, and the goal is for the sequence to look at these different sources and ingest it and be able to ask a question based on those sources that was provided. If the source is blank, then it means it's used the same sources, and this is to show that the activity or the LLM interaction is memory backed, so it has memory of the chat history from the previous question that is asked, right? And yeah, let's just see how this works. So I'll just run this. So this is just initializing the different properties for the activity and going to each row, and then before I can run this, I need to run the Docker container of this is the Python API serving the back end for the API. So this setup is part of the usage guide for the custom activities which I mentioned earlier. So just run that and then run this particular So while it's running, I'll show each of these different sources, what it contains. So this is the DU CSV, the queue item, contains different queue items that were processed by a bot. So I have to close this config file and then rerun. So this is the first, if I run it, so this is the first document. And then let's look at the next document. This is an appointment, a PDF. And then the last source will be a YouTube link.
Okay, in this video,
which is a 12-minute video about Llama 2 usage with Langchain. So now let's rerun it. And again, I'm currently running the API as in a Docker container, so this can be run in a remote server. When you deploy this in production, you can have a remote machine or proper server which you can deploy this API backend in which the custom activities are interacting with. So let's see how it works. So when it ingests the source, so when it goes to the ingest knowledge source, it basically gets the whatever source that you provided. In this case, for example, the CSV file, reads the content of those, whether CSV, PDF, or a video which loads the transcript. So let's say it's a CSV, and then generates embeddings out of those, which are numerical representations of the content, and then pushes those into the vector store for later use within the converse with context, so that it can do a similarity search. Whatever it gathered from the source, the most relevant to the question that I have, and let's say the question, what are the unique queue items? So this question will do a similarity search on the full content of the current document. So whatever has been gathered will be injected into the prompt call to the LLM. The top, let's say top 5 or top 10 relevant chunks will be injected into the LLM after the similarity search is done, and then the LLM will be called, and then it will be able to provide this response, as you can see here. So if you look at how it works in the back end, so it gathered the relevant chunks of document. I ask what are the unique queue items. So, and then it will it will generate the LLM chain. This is the prompt template. It's the full prompt template with the injected content, most relevant chunk, which is here from the CSV, delimited by 3 triple dashes. And then this is also part of the prompt template, and it also has placeholder for the chat history, which is generated from the code as well. And then this is the human prompt template, which contains the question that I asked. Right? And once the LLM chain finished, it will provide the answer, which you can see here. And so in the third question, I asked, what's my last question? So in this case, since it has access to the chat history, it could be able to point out the last question right here. So this is the chat history. My first question would be, what are unique queue items? And then this is the response. And then the next question, enumerate top 3. And then this is the response. And then I asked, what is my last question? It was able to know that the last human message, which is me, was this one. So this is sent to the this is what is sent to the large language model call. So now, so you can see the output from the large language model, and this is how a simple sequence of the model or of the activities look like. So now let's look at the other sample implementation that is included in the workflow. But before I do that, let's walk through this LLM framework template that you can see right here. And as I said, there are a couple of state machines that included here that some of it resembles the RE framework. In fact, I have used some reusable components or reusable modular components from RE framework here, and these are the framework components that is in each of these state machines. So first is initialization stage, which is if you're familiar with RE framework, I lifted this piece from RE framework where it calls on the settings initialization or app initialization, killing the process. So in case you want to use this for a transactional use case, you can use this modular components to initialize all the configurations that you have and settings, of course, from the config file. What's been added here on top of the RE framework initialization is initializing the sources, right? And this is being used particularly for chat mode, where I will show you later the flow of steps when using this framework in a conversational way. So this calls on the modular initialize source, that SAML file. methods which contains the ingest knowledge source activity, which I showed earlier. And this is using the global config parameter, which comes from the init all settings, that reads the config xlsx file to provide the different properties for the activity, the API key for vector store, the API key for LLM, and this is how the config file looks like. So from here, you could be able to provide the base URL. From this point, this all relates to the custom activity configuration. And first, you can provide the base URL. This is the host or remote host where you run the Docker container, right? So if you run it locally, then it will just be localhost and port 5000. This assumes that the Docker image is deployed locally, and you can change this to proper remote host name where the Docker container is hosted. Then the API timeout default is 300 seconds. And for the vector store, this uses Pinecone as a vector store. You can provide the API key here, vector store environment, and index name. So go ahead and watch the setup, custom activity setup, on how you can get these different values for the vector store Pinecone. In this part, you configure the OpenAI API key, which LLM, or you're using OpenAI, or you're using Anthropic Claude, and you can provide the that API key here based on the LLM activities. For this one, OpenAI API key, you have to provide, of course, OpenAI as noted here, and this is the one that's used for the embeddings generation. So for LLM modeling, if you're using Claude, either use Claude 2 or Claude instance, so that's what you specify here. So these are the custom activity properties that you can just configure here, and all of it will be already fetched using the initialize init all settings and initialize source for use. Right? So that's initialized source. Once source is initialized, coming from any sources that you have, documents or YouTube links, then if chat mode, it will go ahead and go to LLM interaction. If transaction mode, it will go to get transaction. Let's say if it's chat mode, you have initialized already the source. So this is how the LLM interaction state machine looks like. It calls on the interact LLM, which is where the converse with context is. So if not transaction mode, meaning this is chat mode, so it will just be provided with the different it's pre-configured with the whatever you have in configured XLSX, and most importantly your particular query or message in chat mode, and the source and context coming from the initialized source. If it's transaction mode, the initialized source will be called in here, since in transaction mode the source will come from a queue, right? Let's say you have a contracts documents queue. So in this case, in transaction mode, it will go from initialization, then it will go to get transaction from a queue, then from that get transaction it will go to LLM interaction, and then here, and then in here in transaction mode it will initialize source based on what is in the queue item, and again it will call this initialize source, and then it will use that source in the converse with context multi-input LLM chain, which has the model with the context document, most relevant chunk. Let's say from a 100-page contract, you ask something about the entity, what are the entities involved, the parties involved. So it will only get a chunk of the page 1 and a chunk of the page 50, or a chunk of 3 other different pages, and use that as a context without providing the full document, which conserves the token from the LLM model interaction, right? And this is also memory backed, so that's what Interact LLM is. And at this point, there are 4 different pathways that, or 3 different paths it can take, right? It can either end the transaction or end interaction. If it's chat mode, it will just end interaction per message that you send. If it's transaction mode, if there's no queue item, it will end interaction. Or if in transaction mode, it can be pushed for human validation, let's say human review of the output for the contract extraction, let's say. And you could be able to update this action center placeholder for the custom form that you want to push a user for human review. Or it can do downstream action based on the output from the LLM. You want it to perform actions, so it has placeholder as well for you to interact, let's say, with your ERP, right? To upload the contract. So this is where you create those modular components. Or you can go ahead and post-process the response, whatever the post-processing that you need to do, without doing any downstream actions before catering the next transaction in the queue, right? Again, it's either post-processing before getting to the queue, or performing actions then doing post-processing after performing those actions, or pushing to human for review, where you have placeholder for action center, like so. You can define the action center custom form here. I will show a sample implementation of the transaction mode in a bit, but this is how the different states look like. And you can be able to define a rule on to which step it will go through next on this reusable component called interaction flow rules validation. And there are, as mentioned, there are 4 possible routes. If the output of should validate is true, then it will push for human review. If the output of should act is true, then it will trigger perform actions to initiate a downstream RPA process. And after perform actions, it will do post-process response. And should act is false, it will just go ahead and go to post-process response, immediately executed to initiate any cleanup or post-process step before completing transaction. And should stop is true, and it's a current interaction. So this is where you can define custom business rules to define which flow for a particular transaction will execute. Okay, so that's a quick overview of the different state machine of the framework. And of course, the interaction is just a log message of completing a transaction or a particular chat interaction with the framework. So let's walk over to some of the sample implementations, one for the conversation mode and one for the transaction mode. So this, I have a SAML file that I have included in the framework to do a sample implementation of the conversation mode. And what this sample implementation require is, of course, an interface for the user to chat or to converse. Since this is conversation mode, I created a form, a sample form here, quick and dirty implementation of a form, and to depict the conversation mode using LLM Framework, and I'll run this in debug mode. So this is a sample form for me to interact with the large language model, context aware, using LLM Framework. So there are two main features for this form. One is it can ingest source, and then you can interact with those source using this text box right here. And each of these functions is wired to a trigger. So if I click the create vector, it will call on press create vector, which basically calls on the LLM framework and feeds the whatever source that I fed. And this is how the LLM framework summary is being called. So it provides a source path. If I click press create vector, it provides a source path. It doesn't provide a query because it's just ingesting knowledge source in conversation mode. So it goes through the initialization and then ends the interaction. And of course, transaction mode is false, and without the AI response because it's just ingesting the source. Right. So if I do that, let's say I choose a PDF file and I load up this appointment receipt and I create vector from source. So it performs checks and then goes to the initialized source, ingesting the knowledge source, and then goes back and provides the ingested context. So this particular file, the content of this file is already in the vector store. So now if I type in here, let's say when is the appointment, so what it will do is call on the it will trigger it has triggered on press send, which also calls the LLM framework, gets the input from the text box and also the context, and provide that user message, the question I added on the text box as a user message, and provides our AI response, and then routes back to this form. So the source is not provided because it's already ingested from the create vector source, and it's assigned to a vector store variable right here, this particular namespace or context that I have ingested. Right. So I can ask another one, let's say summarize in 20 words. So this is still working in the context of the provided document, right? So this is the summary in 20 words, and if I choose another source and then create a vector, again it will call on the ingest knowledge source right here. Make sure the content is in the vector store, and when I ask a new question, summarize in 20 words, now it will provide response in the context of this document, let's say a 50-page MSA, for example. And then just to show the memory, showcase the memory, I'll ask it to summarize this whole conversation. And it's able to summarize right from the start question that I asked, like so. Great. So that's how conversation mode works. So you have to provide an interface or a similar input form where you can interact, like this sample use case, like chatting with your own sources, selecting the source type and that it supports, and then being able to converse with that particular source. So you could be able to change how this form looks like based on your requirements, but this is a sample of how conversation mode works. And let me quickly show solution architecture before we move on to the transaction mode. So again, this can cater both conversational and transactional use cases and uses these activities to interact with different LLM in a context-aware manner and memory-backed using this different activity. Ingest knowledge source, to create embeddings and push to a vector store, and converse with context-aware multi-input chain. Multi-input meaning it uses an LLM chain. You can provide memory, you can provide the context, so it becomes a multi-input LLM chain. And the LLM chain, because it provides different template for system and human prompt template, which in this implementation is a generic Q&A type of prompt template, so it can cater any type of sources, and you can ask any questions or provide any instruction on how to extract on this, let's say extract on these different sources. In the future, I'm planning to add a agent, which is also another type of LLM chain, which is a goal-oriented. You provide a goal or specific goal that you want the LLM to do, and it will have its React framework, which means reasoning and actions. It will provide observation, thoughts, and then provide suggested actions or next steps until it reaches the goal that you provide initially. So it will reiterate and perform observations and thoughts and actions until it reaches the goal that it provides. So if you're familiar with AutoGPT, that's a similar concept with AutoGPT. And this API is hosted Python API in the back end, which is Dockerized, so you can deploy it in your own host or server. And this custom activities can be used within the LLM framework that I just showed, so you'll be able to interrogate with the different sources and converse with context, and incorporate human in the loop, or perform downstream actions or post-processing within the framework itself. The first one I showed sample is a conversational. If you ingest knowledge source, you go from initialization to and then it ends the interaction. And then once you click send your message in the chat, it just goes through this in iteration. Every message will go through these three states, and that's how the conversation mode works. Now this is the sample that I just showed you, chatting with your own data, sample implementation with the sample user interface. Any source, you can choose document or source, and then it will create vector store using the ingest knowledge activity that is included. And then once you ask a question, it retains a memory, and using that source, it will do semantic search and then provide this, inject it in the prompt, and then it will provide a contextual response. So you can have a much more reliable output or answer from the LLM, and at the same time, you can conserve token usage. So going to the next other category of use case, which you can have a surplus of use cases around transactional interacting with LLM. So this is how the interaction looks like. So it goes first initialization to initialize all the configurations that you have, the API key, the endpoint. Once that's loaded, it will go ahead and fetch the different queue items from the queue that you provided in the config file, and then it will push to this state to ingest the current source that is in the queue, and then converse with that source, and based on the custom rules that you set, the validation business flow rules that you set in the placeholder reusable component, it will either go to wait for human action, or perform downstream action, or just post-process the response, and then it will just continuously do this, right? And consume your queue items until it completes. One example implementation that we have here is for contracts indemnification use case, where you have there's some sample contracts that I've included in the framework. This one and this one. So what I want to do for this use case is I will leverage the LLM framework to process these contracts and be able to determine if each of the contracts in the queue is either a one-sided indemnification or two-sided indemnification. So what does the indemnification mean? So if I look at the sample transaction mode, so indemnification is in a contract is a contractual clause that shifts liability, costs, and expenses from one party to another. So after the LLM agent is used to identify and if an MSA document has one-sided or two-sided indemnification, it will push to a human for further review via the custom action center form that is also included in this implementation. So how do I achieve this use case using this framework? Is so it's easy, right? So let's say we have this contracts in the queue already. So this sample transaction mode, what this just does is this is just filling up your queue the queue items with these documents, right? So let's start by creating a new LLM framework process, and let's call it, this is the studio template, the same template that I showed you. This is published in the marketplace. Let's say I name it contracts indemnification review. So let's see how we can update this LLM framework so it can cater transaction mode use case that we just defined. And I'll just make sure I have my queue set up. So let's open config file, and then my queue name should be contracts queue, and then the storage bucket name could be contracts document, which you can update as well. So I go to orchestrator and I check my queue. So in here I have my contracts queue, and I have dispatched these two contracts in the queue. If you're yet to dispatch the document, you can run this sample transaction mode, but make sure again you have the contracts queue and contracts document storage bucket set up. So the storage bucket I have here, and if you want to push this items in the queue, you can just run this like so. So again, this is just dispatching. This is not yet the LLM framework performer. So, and I should have this closed. And then it should dispatch to the queue that you have. So I'll just remove the other one. So I'll be retaining the two unique samples right here. So first, so in order for me to run this in transaction mode, I have to make sure, of course, that the transaction mode is set to true, and based on this, the query, I should be able to provide the query or prompt that I'm using for all the transaction. In this case, the query would be something related to my purpose, which is to identify if the document is a one-sided or indemnification or mutual indemnification agreement. So this will be my prompt that will be injected into prompt template that will be used for each queue item. I'll just provide it here. So what I put in here is Provide example from the text to justify your answer. If both parties agree to indemnify each other, it is mutual indemnification. If only one party, blah blah blah. This example, and provide examples of clauses justify your answer. So this is my query that I will provide right here. Okay. And then since this I'm enabling human in the loop, so in the config file, so I'm not providing any custom rules or flow. I just say always validate, so it will push to human in the loop. It will go here for each transaction. It will go here. But if I want to provide a custom rule, I set this to false. And then I update this interaction flow on the interaction flow rules that I based on the particular queue item that I'm processing. But in this case, I'll just leave this as default to true, so it will, each of the transaction will be pushed to Action Center. And since this is with human in the loop or persistence, I need to enable persistence here, support persistence. And finally, if you look at this state, so this is where my Action Center placeholder is, and this is already pre-built for this particular use case placeholder sample implementation. So this is the indemnification review, where you have the LLM response and then the document here. And in here, there's a comment right here for transactional with human in the loop. You should add a wait for task and resume here. This is not added as default because if it's used in conversation mode and support to persistent is false, this will encounter compilation error. So in this case, if you want to add human in the loop and you want to wait for action, then you just need to add that particular activity here. Wait for task and resume, and then the input and output are variables are already here. Okay. And then after human in the loop, it will just go directly to post-process response. And as default, the post-process response doesn't contain anything, but you can add post-process response here. But in the human in the loop, there's a placeholder, a SAML or reusable component for after resume workflow. So after the workflow has resumed from you in the loop, what are the steps that you want to do? So this is included here, right? And in this case, there's a default that just sends the email, serializes the output from the form, and then sends an email to a recipient, let's say. And this is a configurable field, so that once you use this template, make sure that this will be configured before publishing or before running. So, and you can configure it in, but depending on your use case, you can catch that action or what button has been selected in the form, and then you can add a new case here, and then do the after resume workflow, whatever needs to be done after the form has resumed from suspension. And then of course after that you can this particular reusable component will be again called for you to implement your own flow, whether it will go through downstream action or go to post-process response, depending on the interaction flow rules validation that you set up. Okay, so now let's go ahead and run the LLM framework. Let's say publish this, so this can be run as main file. So you can, I'll go ahead and run this as debug, and it's pointed to that particular queue that we have our contracts. So now it was able to process the first contract in the queue. It's already in progress. If you go to actions, so this is the LLM output, and then you can assign it to yourself and then provide a view feedback. This does not provide any definite answer, because probably it doesn't have the indemnification clause, and I can mark this as a reject, and then it will go to the after resume workflow, which will send the output to me as an email and the status of the contract, and then it will process the next transaction in the queue. This is the output of the first transaction, or the notification. Reject, give feedback, view feedback. So you can define your own downstream or after resume workflow. And let's see the output of the next contract. So here's what it says. So it appears to be a one-sided indemnification because of this section. And this is the verbiage from that section, and then another section that was here. And I can say with this sources or relevant chunks that it was able to provide, this is good to proceed. And accept. And this is again an example of the transaction mode, how you can use this LLM framework in a transaction mode by providing a predefined prompt that will be applied for all the transactions that you have. So you notice the main difference is in a conversation mode, in a transaction mode is in a conversation mode you have different message or question or interaction for every LLM iteration. For transaction mode, it's a queue based. It consumes on whichever queue that you have, and for each queue you would provide a predefined message or question or instruction, so it can consume that in a transactional manner. So let me show you another example of a transaction mode. In this case, it also deals with contracts. But in this case, we're not checking if it's one-sided or two-sided indemnification. What we're doing is we'll try to extract something from this sample contract. We'll extract some entities from this, let's say, 50-page agreement. We will ask the large language model to summarize and be able to extract the deliverables coming from this. And similar to what we did previously, this should be in the queue. It should be pushed to the queue. So the queue that we'll be using in this contracts Q2. And then let's just clone one queue item and run this. So the difference between this the previous transactional scenario versus this one is, of course, the query. For here, the query would be this text right here: summarize contract and enumerate vendor deliverables. provide deliverable output as a JSON array, so you can specify the output type, and then in this JSON array, you have the section number and verbiage, where section number is the section or article where the verbiage is lifted from, and the verbiage is the actual text depicting it. So we're instructing the model. So for each of the contract that will be processed, it will output this JSON in this format, the summary, and the deliverable, so we could be able to post-process or parse it and put in action center form. Only send the JSON output as a response without any other text, so it will be easily parsable. So this is the query, and then let's just run this as it is and see how the output looks like. So let's see, while that's running, let's see what's happening in the back end. So it ingested the document and then gathered relevant chunks out of the document based on my question. So this is the full prompt that was fed into the LLM. So it didn't push the full text from the document, because again, that's very inefficient. So by using this activity, I was able to get the relevant chunks and use that in the LLM and get the output from the LLM. And this is what the output looks like. So I asked it to summarize. So this is the summary. I parse the JSON output. So the JSON output looks like this. So like this. So this is the JSON output based on my instructions and the different deliverables. And once it's parsed, I can easily parse it and show it in a data table in a form like this one. So that's the different sample implementations that it included in the LLM Framework Studio template. And as you can see, it's very versatile to cater any type of conversational and transactional use case that you can freely customize as you wish based on your requirements. That's all I want to cover for this session. Hope you learned a few things on how you can leverage this LLM framework for you to quickly implement any type of LLM based automations that or use cases in your organizations.